Alright, so in this video we're going to do another example of finding the inverse Laplace transform of a function from a table. That same table that we were looking at earlier. So we have the function 7s over 4s squared plus 1. So basically the essence of the inverse Laplace transform is to have a table or some way of trying to match your problem to the form of one of the forms in the table. Now if we look at the table, this doesn't really look directly similar to anything. It might look like something like the cosine one, right, when we have s over s squared plus k squared. But we have this 7 here and we have this 4 here. So if there's some way that we can actually manipulate this problem so that it looks more like one that we guess might be the right form to have it in, that's what we're going to want to try first. So in fact, let's look at step 1. Suppose if we rewrite this 7s over 4s squared plus 1 as a 7 times s over 4s squared plus 1. So we're going to pull the 7 out here. This almost looks like the cosine transform, where we have the s over s squared plus k squared, right? Because now we know the constant's not going to get interfere, because we can always move constants all the way out in the front, and we can take the Laplace or inverse Laplace transform of whatever we're multiplying by. So the only problem seems to be that we have that 4 here, right? In the cosine transform, it's just s squared by itself. So what if we factor a 4 out from the denominator? And so instead of 7 times s over 4s squared plus 1, we pull a 4 out from the denominator here, and we're going to end up with 7 over 4 times s over s squared plus 1 over 4, right? Now notice that these two are perfectly equivalent. If you multiply the 7 over 4 back in, you'll get the same exact original problem. But now we actually have this problem here in a form that we can work with. So notice that the inverse Laplace transform of s over s squared plus k squared, a problem that looks like this, the inverse Laplace turns out to be cosine of kt. So comparing that to our problem, 1 over 4 is where our k squared would be, right? So that means that k squared equals 1 over 4, which you've already written there, and k is equal to 1 over 2. So k is equal to 1 over 2, so we have cosine of 1 over 2 t, right? And in step 3, we just put back the constant that we had pulled out. We had 7 over 4 pulled out. We found the inverse Laplace of s over s squared plus 1 over 4. And so we just combine everything together here, and we have 7 over 4 times cosine of 1 over 2 t. So that's the essence of using the tables for the Laplace and the inverse Laplace transforms. You always want to get your problem. It's not always going to be in a direct form that you can plug in immediately. Sometimes you have to fix it by factoring numbers out and trying different things to see how you can put it in one of the forms that is given in the table.